Welcome to WasmAssembly episode 15. After the last episode with two members of Google's Star team, today I have yet another Google on the show, Thomas Lively from the B8 and WebAssembly team. Welcome, Thomas.
Thanks, Tom. It's great to be on the show.
So there's this running joke about the too many Thomases on the Wasm team, with Thomas Nadestad, whom I've had on in episode 7, and who goes by Thomas, yours truly, Thomas Steiner, host of this show, who goes by Tom, and then, of course, you, Thomas Lively. So someone recently suggested that you should just go by Tommy. Would that fly with you?
Was it Nadestad who put you up to that? No, that
I
would
won't
not
name
fly.
any names.
Oh, you won't name names.
But
Well,
it was not Nadestad.
was it Nadestad? Well, no, I don't think that would fly. Thomas, please.
All right, so the confusion will just be everlasting. Okay, then.
Yes.
That's fine with me. So your career has so far been pretty impressive, and I'm sure it will continue to be impressive. So you joined Google straight from Harvard. Whoa. After 2 internships at Google. So can you tell us how you got into the company, what background you had at Harvard, how it went, how you got into Google's compilers, all that thing, WebAssembly eventually. So 2 internships is also great. Like people do typically 1 internship and then get into the company. You did 2. So as I said, impressive career. So tell us more about it.
Yeah, so I was studying lots of computer science in school, of course, loved programming, and who wouldn't want an internship at Google? So I applied. I was lucky enough to get in. And then the interesting thing, at least at the time, I think they still do it this way, is that I got the internship and only then did they do project matching. So I knew I had the internship, but I had no idea what I was going to be working on. And then I got a call, and it was from a member of the native client team. And native client, of course, is one of the predecessors to WebAssembly.
Oh yeah, we did a show on that with Alan Zakai. Like it was actually the first episode. Bad audio quality, but it was like very interesting discussion. So definitely go back to it.
Yeah. So basically, WebAssembly didn't exist at the time. So it was the native client team. And when I arrived in Mountain View for my internship that summer, sure enough, I was working on some native client project. But in the meantime, the rest of the team had become the WebAssembly team. So everybody else was working on WebAssembly, and I was working on native client. And then at the end of that summer, one of the team members said to me, Thomas, it's been great having you, but you should really, have a diversity of experiences. You should go work at a different company next summer, or at least a different team. And that guy was my intern host the next summer because I was back on the same team, this time working on WebAssembly. This was actually, I was working on the WebAssembly backend in the Rust compiler that summer, which was pretty fun. And then I went back to school, finished up, graduated, and came back to the team full time. So I've been, if you count the internships, it's been like 9 years on the team, which is pretty cool. If you don't count the internships, only 7. But it's been really great.
Amazing. Yeah, I'm in a similar boat actually. Just everything else about my career is not impressive. So I also did 2 internships at Google and then got hired full time. It's my only job so far. So whenever people ask me like, "Hey, how many years do you work at Google?" I have the same situation as you are in, where I'm like, "Yeah, like if you count the internships, it's X, and if you don't count them, it's Y." So yeah, I love that you made a lot more progress than I did. I'm really happy that it works out for you so well. So actually, it works out so well that you're now chairing or co-chairing the WebAssembly Community Group, taking over from Deepti. I had Deepti on episode 2, so definitely also go back to that if you're interested. So I thought it would be just interesting to get some of your takes on the 3 questions that I asked Deepti back then. And my first question to Deepti back then was, you are active in both the W3C WebAssembly Community Group and the Working Group. For those not super familiar with the W3C mechanics, could you tell us what's the difference between the 2? Are they competing? Are they collaborating? What is the difference? And if you are not into W3C kind of things, that's where standards happen for web in many cases. And they have this low-key community group kind of concept, and then the standards making WG working group model. So yeah, you are on both. One you co-chair, the other you're a regular member of. So yeah, what is the difference? What do you go? What do you get to do in books?
Yeah, absolutely. So the W3C is the World Wide Web Consortium. And as you mentioned, that's where all the web standards happen, including WebAssembly. So traditionally, these working groups are sort of composed of full paying members of the W3C. And these working groups are the ones that really have the power to officially stamp a standard and say, this is a W3C recommendation. This is the standard. Uh, Community groups historically have had more of an advisory capacity. So they're free to join. You don't need to be a paying member of the W3C. You just sort of sign a policy about patents, and then you're good to contribute. It's very low bar. And so historically, these have been for getting wider community input on proposals that have been developed in the working groups. For WebAssembly, we deliberately wanted to do something a little different. So for WebAssembly, it's the community group, the one that's free to join with the really low bar where anyone at all can join. That's the one that actually does the entire process, the full design process, consensus on the new features. We advance through these phases we have in the specification process. And then finally, the community group says, yes, this feature is done. It's standardized. We'll never change it again. And then the working group comes along and says, yep, rubber stamp, sounds good. And that gives it the full W3C sort of officialness that only working groups can give it. But that's literally all they do. They just stamp the thing and say, looks good to me, and lets the community group carry on with its work.
That's cool. So a couple of questions I have there. So you have mentioned the phases concept that I think TC39 with JavaScript also goes through. But then also, like, you sort of sidewalk the working group for most of the work that typically does happen in working groups. Has someone from the W3C ever commented like, "Hey, you are creatively abusing the way this should be working," or are they fully aware, fully okay with the way this works? Because, as I said, you don't have to be a W3C member to effectively contribute to WebAssembly standardization, which I think is great. But like someone at the W3C might not think is such a great idea. I don't know.
Yeah. No, we've never heard anything about it. Everyone seems pretty happy with our working model. And in fact, I think we're in a better situation than some community groups because what I've heard is, I don't have firsthand experience, but I've heard that there are some community groups in the W3C that do a similar thing where they sort of like do all their own design and sort of publish their own specs without having the working group to go along with it to actually give it the stamp of approval. So we're in a pretty good spot because we have a very clearly delineated path for the CG to design something and then for it also to become official through the WG. So I think it works quite well.
And then my next question would be on the chartering. I know it's always a big thing with the charter of a working group, but then if all the work happens in a community group, how do you make sure that a charter, which is somewhat forward-looking, is accurate and doesn't need standard consistent tweaking to be reflective of the actual standards work?
Yeah, absolutely. So the charter says, what are the deliverables that the group will produce? And so it's fairly broad, right? We'll produce, relevant WebAssembly features. And then when we want to do new things, like the component model, for instance, which is kind of built on top of core WebAssembly, or WASI, the WebAssembly system interface, which is a bunch of APIs, again, on top of WASI, or on top of WebAssembly. We can actually amend the charter, right? If the group decides, hey, there's a new kind of deliverable that we want to work on, we can amend the charter. And yeah, it's a bit of a process. There are a bunch of lawyers involved from a bunch of companies, but we've done this once or twice and it's gone fairly smoothly. So we do have some flexibility there.
That's great. Like, I really like this model, especially because they don't have this challenge that you mentioned where the community group does all the work and then they have nowhere to go because there is no corresponding yeah, working group to rubber stamp. I think it also works because comparatively, it's still relatively small. So if you look at some of the like bigger community groups with hundreds of typically mostly inactive members, I think everyone in the community group is relatively active compared to like most of the people who lurk on a group but never really do anything.
Well, yeah, interesting you should say that. We do have about 30, 35 folks who show up to our biweekly video calls for the community group. And yeah, it's usually the same faces every time. People are fairly engaged. But if you look at the W3C website for the community group, you can actually see a list of members, and there's something like 1,500 members. And of those, we ever hear from maybe 50 of them. So yeah, there's a lot of inactive members, but it's not really a problem. That just means they're subscribed to our mailing lists.
Oh yeah, yeah, makes sense. I thought it was a lot less, but yeah, true to know that the community group is
There's a
still
lot.
held together by a few very active members. Then,
Yes.
cool. So my second question to Deepti back then was, standards have a reputation of being kind of slow, and it's not unheard of for several years to pass from someone having the initial idea to the thing becoming a finished standard. So, in your opinion, is WebAssembly standardization relatively fast by whatever definition of fast, or do you think it's rather slow and you wish it went a lot faster?
It's an interesting question because it varies. Sometimes we move fast, sometimes we move slow. I think the big thing is just how much work goes into standardizing one of these features. Uh, all the JavaScript and WebAssembly engines have to be on board with it. They have to implement it. They have to prototype it. We need to get experimental data showing that it does what it aims to do, right? The tool chains, the compilers, the optimizers, they have to be updated to support the new feature. And again, go through this experimentation and feedback phase. And developers, right? You can't run these experiments unless you have developers actually trying it out in their applications, right? You can do benchmarks, but it's just not the same. So you need developers to try out the new feature. They can only do that after tool chains and after engines have implemented it, right? So there's a lot of things that depend on each other that need to happen. And then there's all these different constituents in the community group who all have different priorities and all need to align and get consensus on the feature, right? So we're very lucky to have a large group of academics, right? University researchers who participate really heavily in the WebAssembly standards process and contribute a lot to the design of WebAssembly, make sure that it's sound, like literally sound, like the type system has to work. And so, they have a lot of constraints and things that they're trying to optimize for that maybe an engine implementer isn't trying to optimize for, right? So all these different people, all these different groups have to come together and develop the feature. And the first idea does not win, right? There's iteration on the design. So I think it's working as intended that it goes slowly. If you tried to go really fast, you'd end up with a much, much worse design. Maybe it would be a better design on one metric, according to one group, but it would overall, when you look at how everyone uses and thinks about WebAssembly, you'd end up with a worse result. So I think it's, it does take on like the order of years to standardize something, but I think it's time well spent. And sometimes we really do move fast. So we'll talk about custom descriptors later, which is a feature I'm currently championing. We're moving really fast on that. We were throwing around initial ideas in October last year. We went to phase 1, I believe, in February this year, and we're currently hoping to go to phase 3 in October this year. So that's basically 1 year it'll be from initial sort of vague ideas, not really knowing how to solve the problem, to a phase 3 proposal. And we're hoping to have an origin trial in Chrome and all this stuff, right? So actually that's moving pretty quickly, I think. You might hear, oh, a full year, and it's not even done, that's taking forever. But I think the pace has been really rapid on that. And it's great. It's great to know that we can move fast when everyone focuses on something.
Yeah, makes sense. So actually, when I joined the community group as a very acknowledgedly relatively inactive member, I was really surprised to see how much the academics actually dominate some of the meetings. So actually, when you go to a community group meeting, there's always a research day, the day before or the day after the community group meetings. And you mentioned implementations before. So do you ever hit this problem of like the ivory tower, where academics think like this is really something that is scientifically sound and pure, but then if you ask the implementers, it's like, oh, come on, can we just make it happen, implement it, and not think about corner cases that much? Like, is this a problem, or is this actually something that helps you design better things?
Yeah. So, different people have different opinions here. I definitely think it's a good thing. So for example, a lot of the academic members of the community are very deep into formal verification of the WebAssembly spec, right? So they are formally proving statements about WebAssembly's safety guarantees, and sort of the things that can or cannot happen when you run a WebAssembly program. And for these formal proofs, they need like really clear abstraction boundaries, right? It can't be mushy. It can't be vague or ill-defined. So there's two results of this. First, we need an extremely formal specification, because any sort of hand waving is simply not going to work for this academic contingent. So they insist on having everything totally formalized. And this is great. Everyone benefits, right? It's really great when there's just absolutely no ambiguity in the spec and it says what it says and there's just no question about it. That's good for everyone. And then there's other cases where, for performance reasons, say, an engine would really love to just punch through a bunch of abstraction boundaries and observe the inner workings of a WebAssembly module to make something happen in JavaScript, say. And first of all, that's like questionable design. Abstraction boundaries are generally good. But second of all, that causes brittleness, right? If you try to go add new features on top and you've punched through all these abstraction boundaries, what's going to happen? Yeah, you have to add extra complexity to work around it. So the academic contingent, they really insist on like having these nice abstraction boundaries. And I think in the long run, this is really good for the design, even though it forces us to get creative, say, and find interesting solutions that we wouldn't have initially thought of, that both preserve the abstraction boundaries and get us the performance we want. And we've actually done pretty well at that. It's worked out well. So yeah, I mean, this causes frustration among various members of the community group occasionally, but I think in the long run, it's working quite well, and we've been able to resolve everything that's come up.
Yeah, I'm really glad to hear that. And as I said, people may have different opinions. If you're interested in Deepti's opinion, definitely go back to her episode. And talking of Deepti, the final question that I asked her about her role as a co-chair of the community group was around Google's positioning of WebAssembly. So for background, we both work in Google's Chrome team, and Google's V8 team is part of the Chrome organization. There also is a core Wasm team that is outside of Chrome, outside of that org, but you and I, we are both part of Chrome. So with WebAssembly being a thing that's becoming increasingly popular to run outside of a web browser, do you see any challenges for the WebAssembly team at Google to be part of the wider Chrome team, or do you think it's just fine where it is? Do you think we should be combined with the core Wasm team? Like, what is your take on that?
Yeah, no, it's a good question. And it's really exciting because there are so many teams at Google working on WebAssembly. And as you know, our mandate on the Chrome WebAssembly team is really all about the web, right? So we don't participate so strongly in the WASI subgroup, for instance, or the component model stuff, which is really being driven by the server-side WebAssembly folks. But I think that's okay, right? Different people can focus on different things. And if there are other teams at Google who want to get involved in that stuff, they're absolutely welcome to join the community group. We'll help them out. We'll support them. We'll give them an introduction and then let them know how things work. And we'll do everything we can to help them be successful. But that doesn't mean we need to be championing those proposals ourselves. And so I think we have a pretty sustainable model here, and it works pretty well. And yeah, All right, it's exciting. As you said, so much interest off the web in WebAssembly. Sometimes I do wish, we could focus on that more, but really the web is also at the vanguard, right? We're pushing WebAssembly forward a lot in ways that, off the non-browser use cases are just catching up, right? Wasm GC, right? We're pushing that as hard as we can. A lot of these new proposals, sort of, we do them first on the web, and then later the non-web engines catch up. So it's exciting to be on the forefront of a lot of those new developments.
Yeah, very interesting. So, if you were to estimate, do you think WebAssembly is now these days globally run more on web browsers or on servers somewhere or cloud edge infrastructure, whatever, somewhere out there?
That's a great question. I don't know. I don't know. I have very little visibility into the numbers. You hear about like, oh, this device shipped WebAssembly. I'm like, okay, well, how many millions of that device are out there? But like a web browser is also everywhere. And who knows how many websites are using WebAssembly, right? Any website could just decide to use WebAssembly one day, and then if it's a popular website, all of a sudden, millions or billions of people might be running it. So I don't know. It's a tough question. I do not have the data to confidently answer that.
Yeah, we have some public data on that, at least, where we can see like how many calls to the WebAssembly instantiate or instantiate streaming method happen on page loads. You can get to that on Chrome status if you go to the JavaScript stats. So, but yeah, as I say, we don't really know any kind of like server edge cloud something devices or IoT. It's probably impossible even to answer the question. So I was just interested in your estimate. But if you say you don't know, I don't know either.
Yeah, I don't know, but I sure am excited that so many folks are running WebAssembly for so many different purposes.
All right, so that's amazing. Thank you for rerunning me through your answers that I had to the questions that I had asked Deepti. I thought it was pretty interesting just to compare the two of you because I've been in similar roles. But let's talk about the proposals that you're championing right now. So this is all about Thomas Lively now, Tommy Lively, should I say? Um, sorry, Thomas Lively. So you are currently championing two proposals. There's the shared everything threads and there's the custom descriptors and JS interop. So let's maybe start with the latter, custom descriptors and JS interop. So looking at the core objectives of the proposal, the objectives are save memory and Wasm GC structs and associate JS prototypes with Wasm GC structs again. So it's clearly something that has to do with Wasm GC. Relatively recent addition to the WebAssembly standard. So can you walk us through it? What does it mean? What is described here? What is custom about those descriptions? What is JS intro? Yeah, so give us the run through.
Yeah, absolutely. Okay, so imagine you're compiling Java to WebAssembly. All right. Before Wasm GC, you would have to compile the Java to linear memory, and then you would have to compile in your own garbage collector that would collect all the Java objects in linear memory. With Wasm GC, instead, you can lower each Java object to an instance of a WebAssembly struct, and the built-in garbage collector from the JavaScript engine will just collect it for you. So you no longer need to ship your own garbage collector. All right, so that's the starting point. So we're compiling Java classes to WebAssembly structs. How does this work? So a Java class, just like in JavaScript, it can have a bunch of fields, a bunch of members, and each instance of the class is going to have its own copy of those fields. So each instance of the class is going to be a separate instance of the WebAssembly struct, and that's going to contain all of those fields. Now, Java classes also have methods, right? You can call a method. It would be really wasteful to put a function reference, so a reference to that method, into every object, right? Because every instance of a class shares the same methods, right? They don't need to be copied into every separate instance. So the way this works is that the methods go in what's called a virtual dispatch table, or a V table for short. And what we have is a single V table for the class with all the methods in it. And then each instance of the class has a single pointer to the V table. So when I call a method on an instance, I follow that instance's pointer to get its V table. I look up the method in the V table, and then I call that method, passing in the instance as the first parameter, which becomes this in the surface language, right? So when you compile to WebAssembly, the receiver, this actually becomes the first parameter to the function. So this is all totally possible just with Wasm GC. This is how Java and Dart and Kotlin are compiled today. And the problem is it's a little wasteful, right? So every instance has that pointer to the V table, but what it also has is another pointer that's managed internally by the engine, and that's a pointer to the engine's internal metadata about that instance. So for example, it's type information, so that when you do a cast, it can look up the type information at runtime. So we actually have two pointers now. We have the user space vtable pointer, and we have the engine managed sort of internal metadata pointer. And so the entire point of custom descriptors is to say, hey, what if we took those two pointers and we just smushed them into one pointer? And we can save memory and all of the objects that way. So the custom descriptor replaces the vtable. It says, in the type definition in WebAssembly, it says, here's my struct type representing this Java object. And here's its descriptor, which is another struct type that includes all the methods. So that's the vtable. But because it's marked in this special way in the type definitions, the engine knows it can put all its own information about the type, whatever else it needs to track at runtime, also into that custom descriptor object. And so now, instead of having two separate pointers to the internal and the user space object, we just have one pointer to an object containing both. And so that's very exciting. We've measured in some experiments that it reduces the memory usage of the WebAssembly application by 10%, which is crazy, right? 10% of all the memory in the application was just this one pointer to the user space vtable, and we can get rid of that. So it's a nice little proposal.
So when I say memory, this is runtime memory, right? So it's not about disk space, it's about runtime memory. Like, is this generalizable, or is this like something you observed over a variety of application examples? Is this like the best possible case looking at a very synthetic test case?
Yeah. So it's going to be totally dependent on the workload. This is a particular large app we were looking at, but just one application. It's totally possible that another application would have a bunch of really tiny objects, and so the memory savings could actually be much larger. Or it's possible that an application has only very, very large objects or massive arrays or something like that, so that removing this one pointer doesn't make as much of a difference in the long run. So yeah, it's going to depend.
Okay, makes sense. Cool. So you're going to explain the second part now?
Yeah. So the JavaScript interop. So as you know, the way a method call in JavaScript works is first you do a property lookup on the object. So if I'm calling the .foo method, right, first it looks up the foo property, and then once it has it, it calls it. And that property lookup could involve the prototype, right? So if I do, bar.foo, the JavaScript engine is going to look at bar. It says, does it have this foo property? Oh, no, it doesn't. Let's look at its prototype. Oh, the prototype has the foo property. Okay, now we'll call it. And so that's very nice. This is how method calls work in JavaScript. And it would be great if we could have a WebAssembly library that allowed you to do the same kind of ergonomic method calls from JavaScript. So today in WebAssembly, you can export a function. Right? You can export a function. It can take your object as that first parameter, and then from JavaScript, you can call that function. But you can't call it with that nice method syntax. You can't do, bar.foo. You have to do like WebAssembly.exports.foo and then pass in bar as the explicit argument. And that's just That's not what you would write in JavaScript. It's not ergonomic. And in particular, this is a problem if you have an application or a library that's written in JavaScript and you want to move it to, or you want to port it to be now in WebAssembly, your interface is going to change because you can't have these method calls anymore. So we want to fix that. So the cool thing about custom descriptors is that it's a good foundation on which to build this JS interop support to allow you to call methods ergonomically on WebAssembly structs. So I talked about this engine managed metadata pointer before. In a JavaScript engine like V8, this is actually a pointer to a map. So V8 has a thing called map that describes the sort of hidden internal type of an object. And this is the exact same map that's used for JavaScript objects. So both WebAssembly and JavaScript objects point to this map. And the map is where the prototype is stored. So now that we have custom descriptors in WebAssembly and we said, hey, we're making this custom descriptor thing, this metadata, it's like partially user visible now. We can configure it. We can add stuff to it. We can add fields to it. Now, this gives us a way to actually add a field and have it show up in the map that the object is pointing to. And in particular, we can take one field and say, this is going to store the JavaScript prototype. It's an extern ref in WebAssembly, but the object it's going to point to is going to be the prototype. And when we install that extern ref on the custom descriptor, the engine will know to copy it to the slot that holds the prototype. So then when that WebAssembly object flows out to JavaScript and I try to do a property lookup on it, now it has a prototype that I can look up that property on. And so we can attach methods to that prototype. And now all of a sudden I could do my bar.foo, nice ergonomic method call syntax on a WebAssembly object from JavaScript. So that's the goal.
You're introducing this problem essentially to WebAssembly as well, like this as a JavaScript, but for the good, for the better.
That's right.
So this is, I guess, something that tooling will just make use of. So you as a, whatever, you mentioned Kotlin, for example, a developer, you don't need to deal with this. It's just going to happen in the background. So as always, when you target different engines, some of them might have it, some of them might not have it yet. Is there any way this could be like polyfilled, switched automatically, or do you have to just deliver two separate bundles?
Yeah, unfortunately, if you try to use the new feature on an engine that doesn't support it, then it's going to say, I don't know what these bytes mean. This looks invalid, and it's going to not let you instantiate your module. So really, there's two ways to polyfill it. There's what you mentioned, which is just have two builds of your WebAssembly module, one that uses custom descriptors and one that doesn't, and then feature detect and choose which one to ship. You can also just fall back to JavaScript. I know some tool chains are planning to do that. So use the latest and greatest WebAssembly features, or if they're not supported, just ship the backup JavaScript version of the application. So that's like the core WebAssembly part of the polyfilling. The other is the actual JavaScript interop part, right? So if you're choosing what version of your library to ship, you don't want to have to change the code that uses that library. So the whole point here was to enable this ergonomic method call syntax from JavaScript on WebAssembly objects. And if you don't have custom descriptors, can you do that today? You can, but it's complicated. Basically, what you'd have to do is you'd have to intercept every WebAssembly object that flows out of the module. You'd have to wrap it in a little JavaScript object. And then you would have to install all your methods on that JavaScript object and have them call WebAssembly exports that, and then pass them automatically the wrapped WebAssembly object. So there's a lot of like machinery to hook up there, and there's a wrapper object, so you have memory overhead, there's performance overhead. And then the problem is if the same WebAssembly object flows out of the module twice and you do an equality comparison in JavaScript, you should see that they're the same object. But that means you have to use the same wrapper every time the object flows out. So you actually need to maintain this giant weak map, mapping the WebAssembly objects to their wrappers so that you can reuse the same wrapper every time you see the same WebAssembly object. So it's just like a huge mess, like not performant at all, lots of memory overhead. And so you can polyfill that part, but it's better if you don't have to.
Makes sense. So I think people will just go back to shipping different bundles for various engines that support or don't support the feature. Makes sense. So I feel like you could go on for that on that forever. But you have another proposal that you're championing that we want to briefly discuss with you, or that I want to briefly discuss with you. So it's about shared everything threads. So WebAssembly supported p-threads or POSIX threads for a long time. So apps like Photoshop have been making use of that feature. I gave a Google I/O talk where I explained p-threads in WebAssembly, how Photoshop uses it, and so on. But like the way it works, essentially, WebAssembly threads on the web use web workers with shared array buffer for updating shared Wasm memory. So my predecessor in my role as WebAssembly DevRel, Ingvar Stepanian, if you hear this, hi Ingvar, he has documented this very perfectly in his article using WebAssembly threads from C, C++, and Rust. So in this article, there's already some hints at shared memory, like shared array buffer and so on. But now you're introducing this new concept of shared everything threads, and everything is a lot. So could you just outline what is this everything? What are you sharing more that the existing P threads don't share? Like, what is the difference? What is everything?
Yeah, absolutely. So first of all, I want to acknowledge that this is not a great name, but it's the best name we could come up with because there is a whole lot in this proposal. So specifically, yeah, with the existing thread support you were mentioning, the only thing that's actually shared between threads is the memory. Everything else is separate on the different threads, right? So you have to reinstantiate your WebAssembly module separately on every thread. So at the WebAssembly language point of view, you're actually getting like separate copies of the same function on every thread, and it just happens to work out. Now, internally, there's a bunch of engine optimizations, so the actual generated machine code is shared, but that's sort of an internal optimization, and semantically, these are different functions. So shared everything threads is taking a step further than just sharing the memory. So in the long run, it includes sharing functions, tables, globals, and the new Wasm GC objects, structs, and arrays. So in the short term, actually, we're just focusing on the Wasm GC structs. Because right now, it's impossible to have a multi-threaded Wasm GC application because a Wasm GC application doesn't use a memory, and memory is the only thing that can be shared. So to fix that, we're focusing on getting shared structs and arrays first. And you'll still have to do an instance per thread, and that means you have to have a separate web worker for every thread. But you'll be able to share these structs and arrays and have multi-threaded Wasm GC programs now. In the long run, that's all going to be shared, right? And the benefit of that is that, for example, in a C++ application or C application, if you call DL open to open a shared library, today that has to do a lot of work because it has to separately instantiate that shared library on every thread and populate each thread's table with the loaded functions the same way on every thread. And DL open can only return after all that work has been done. And so that's a lot of duplicated work because you're doing the same exact loading on every thread. With shared everything threads, you'll be able to just load the module once, instantiate it once, populate the table once, and then all threads will be able to see that shared table, and it'll be a lot more efficient.
Whoa, so this sounds like a great optimization there. So coming from a JavaScript angle, something about the existing p-threads is a little bit annoying because for using shared array buffer, you have to set the co-op and co-op or coop, whatever you pronounce them, headers to get cross-origin isolated. Is this something that shared everything threads will inherit, or can we get rid of that?
Yeah, unfortunately, we can't get rid of that. So the same restrictions that linear memory Wasm will have with its threads will have the same restrictions for Wasm GC threads. Now, orthogonally to anything we're doing in WebAssembly, if the web platform makes some improvement there, then we will inherit that improvement as well. But not my area of expertise.
So something I learned relatively recently is those headers will be honored if you set them with a service worker. So if you install a service worker and reload your page so the service worker becomes active, you don't actually have to set them at the server level, which for some hosting environments like GitHub Pages can be a good solution. Obviously, that's not something that you want to do in production, but if you're just hacking around quickly and you hint this problem, think about this service worker solution. There's a library out there called Koi Service Worker, just like the fish, KOI, Koi Service Worker, which is I think it's COI, sorry, cross origin isolated. So COI Service Worker, pretty cool solution there. Just as a quick sidetrack. So you mentioned the duplicate instantiation work. Is this comparable with the way, like the optimization internally that the browser is doing today? Is this comparable with the way that that compiled WebAssembly code gets cached on disk, so you can at least quickly pull it up again without having to recompile? Does it reuse some of that optimization infrastructure?
Yes, so it kind of takes that optimization and moves it into the language level. So right now, the caching of code, the sharing of code across threads, these are all sort of like invisible optimizations that the engine is doing. And what we're saying is like, hey, that's a pretty good idea. We should be able to share the code like that. Let's reflect that in the language to reduce overhead even more.
I'm going to say the engine, you're obviously talking about V8, but is this kind of optimization the same that other engines have applied, like Safari's engine or SpiderMonkey in Firefox?
Yeah, I actually don't know for sure. I suspect so, just because it would be so helpful. And I know non-web engines like Wasm, uh, one of their main selling points is that they can pre-compile the module and then instantiate it really fast by just loading it from disk. So I think this is a pretty common technique across the ecosystem.
Hmm. So let's talk about the phases these two proposals are in. So you mentioned descriptors, custom descriptors went relatively quickly. So what phase is it in right now?
Currently in 2, and we're hoping to get it to phase 3 in October at the in-person CG meeting.
In Munich. Cool.
That's
And for the second proposal, where were we there?
For the second proposal, shared everything threads. It's a bit of a tough story. All right, so it's at phase 1, and it includes a lot of things, right? So there's the main sort of, everything is shared that I mentioned, but there's also new relaxed atomic instructions. There's a new pause instruction. There's just like a whole bunch of stuff included in that proposal. And so probably what will happen there is most of it will stay at phase 1 for a while, and we might chop off bits and pieces of it that are ready to go a little faster into their own proposals that can advance to phases 2 and 3.
That makes sense. So just to speed up some of the non-controversial things, have them in
Exactly.
their separate. That's cool. Whoa! So pretty exciting stuff that you're championing there. Looking forward to seeing where this goes in Munich at the next face-to-face. Which brings us to the last part of the show already. So the last part of the show obviously being Wasm, but not. So Thomas, when you instantiate streaming on any of your streaming devices, what is it that you currently watch or listen to?
Well, I'm a bit of a Star Wars nerd, so I do like to watch all of the Star Wars TV shows on Disney Plus. I'm currently in the middle of season 2 of Andor, and it's quite good.
I don't judge you for that, but I do judge you. So you are a Star Wars person. I did not know that.
Yeah.
I thought you were Star Trek more kind of. Do you like
Oh
Star Trek at
no.
all? No.
Star
Okay.
Trek's Star Trek's okay. It's okay. It's okay. I'll take Star Wars though.
That's a diplomatic response. All right. So, but then last response, like, should Star Wars have stopped after the first ever 3 episodes, or do you think the new ones add value?
Oh my goodness. Spicy take. I love the prequel trilogy, so I think it's great that they kept going.
All right. They lost me at Jar Jar Binks.
I won't do my Jar Jar Binks impression.
All right. And then the last question is, if there's one thing that you could local get, as in something that you do, and then global set, as in something that you wish everyone else did, what would it be? And if you want, obviously, you can, as always, reverse the question.
Aha. Well, I think it's stacked PRs. So I don't know if you know this concept, but like tiny PRs stacked on top of each other. So you don't have to git review on the first one and get it merged before you even upload the second one. And so I have a custom little wrapper script around Git that helps me manage my stacked PRs. But I wish Git supported this better, and I wish GitHub supported this better, because it's kind of a pain to be rebasing all my branches all the time. So GitHub, if you're watching, please do something about stacked PRs.
I can subscribe to that. And if GitHub are not listening, there's this common hack of join the company, fix that one bug that is bugging you, and then come back to Google. I guess you could even come back at L+2 at the amazing level that your career has been taking so far. Cool, cool. So people who want to follow you on any of the socials, who have questions, who may want to email you, who may want to contact you, what is your preferred way of people getting in touch? Or not at all?
Yeah. No, so I used to be on Twitter before it all went a little nuts, and I don't look at it much anymore. But now you can find me on Blue Sky. So tlively.bsky.social. That's me. Honestly, I don't post a whole lot, but that's probably the best way to reach out.
Cool. With that, thank you so much, Thomas, not Tommy, Thomas, for being on the show. It's been great. I learned a lot about optimizations at the threads level. I had no idea how inefficient today's threads work. So thanks for teaching me about that. And yeah, everything else, wishing you all the best for your next proposals that you are going to champion. And yeah, if you are out there and you're not a Google employee, because I had too many Google employees recently on the show, please reach out. I would love to have you on the show. You know how to reach me, you know how to reach Thomas. I'm also not on Twitter anymore, but if you just search for Tamayak, which is my handle with a Y, you will find me on the internet somewhere on Blue Sky, which I'm not actively using, but I'm hanging around. I'm mostly on Mastodon. So if you're interested, find me, Tomayak, and then let's discuss having you on the show. And thank you so much again for Thomas Lively for coming on the show today. See and listen to you next time. Bye bye.
Thanks, Tom.